Welcome to Mimi's Math Channel. Today I'm going to demonstrate matrix operations. But before I do, let's go over a couple of things about matrices. So the first thing is a matrix is basically just an array of numbers that are in rows and columns. And so when you're reading it, you're actually reading it to tell the dimensions or order by how many rows. You list that first by how many columns also. So for matrices A and B matrix, if I go to C and D, I now have a 3 by 2 because I have 3 rows and 2 columns. Now, sometimes you're asked to actually identify an element. So the numbers inside are known as elements. And when you're reading that, the first number is telling you your row that you're looking for, and the second one is your column. So for matrix A, the second row, the second column. So your answer is -1. If you go to B, it's saying go to the first row, second column, the element is 1. For C, go to the third row and the first column, that element is 4. And finally for D, go to the first row, first column, and that element is 5. So now we're asked to perform the following operations. And what you need to know about adding and subtracting is that they have to have the same dimension. So if it's a 2 by 2, I cannot add it to a 2 by 3. They both have to be a 2 by 2 for both adding and subtracting. That's how those rules work. All right, so using the information above, we're going to, in example 1, add A plus B. And all that involves is taking the elements from A and matching it with the elements for part B. So 5 plus 10, -9 plus 1, 0 minus 2, -1 plus 7. And then you just put it in that order. So again, for the first one, 15. And going across, -8, -2, and 6. So for example 2, I'm now subtracting D, so you have to be careful. Anything that follows the subtraction sign, all of the signs in that matrix will change. So all of the elements over in D will change signs because there is a subtraction sign in between those two. So this is 3 minus 5, -8 minus -2, 2 minus 1, 0 minus 7, 4 minus -10, so that's going to change to a plus, -6 minus 9. And so what the elements now look like for example 2 are -2, -6, 1, -7, 14, and -15. All right, example 3, I'm asked now to multiply C and A. So what you need to know about multiplication is that the column of the first matrix and the row of the second matrix have to be the same, otherwise it won't work. So what does that mean? That means that if I am looking at matrix C, the order is 3 by 2. So 3 by 2, where 2 is my column. And then for A, I have a 2 by 2, where this first 2 is my row. So my column and my row have to be exactly the same. So if I ask you to multiply A times C, then A would have been 2 by 2, and then C would have been 3 by 2. These numbers are not the same, so therefore I could not multiply those. I can multiply C times A. Hopefully that makes sense. So in doing that, I'm going to take this entire row and I'm going to multiply it first by this column, and then I'm going to come back and I'm going to multiply it by the second column. So I'll show the work on the side so it'll make sense. So 3 times 5 is 15, and then -8 times 0 is 0. So that's what's going to go here. And also another thing that you need to know is your answer is going to be whatever's left over. So 3 by 2. So I am expecting to have 3 rows and 2 columns in my answer. Okay, so now I'm going to take that same row and multiply times the second column. So that's going to give me 3 times negative 9 is negative 27, negative 8 times negative 1 is positive 8, and once I combine those numbers, I'm going to end up with negative 19. And now I go to the second row, and I do the same thing. First, I multiply by the first column, and then second, I go back and do it by the second column. So that's going to give me 2 times 5, which is 10. 0 times 0 is 0, so that's 10. And 2 times negative 9 is negative 18. 0 times negative 1 is 0. So I'm going to end up with negative 18 here. Go to my third row, multiply times the first column and the second column. And for the first one, I have 4 times 5, which is 20. Negative 6 times 0, which is just going to give me that 0. So I'm going to have a 20 here. And then I'm going to multiply 4 times negative 9, which is negative 36. And negative 6 times negative 1, which is positive 6. And once I combine those terms, that is negative 30. So that's my final answer for that one. Now going over to example 4, I'm asked to use what's known as a scalar. So this is just simply like a real number that you're going to distribute to each one of the elements that's inside of your matrix. So 3 times 10 is 30. 3 times 1 is 3. 3 times negative 2, negative 6. And 3 times 7 is 21. So that's the answer for that one. And then the last example is going to be a combination of multiplying by a scalar, which is this number on the outside, times only this matrix, and then taking that answer and adding it to this matrix. So 2 times D, and then add it to matrix C. That answer is going to be, so 2 times 5 is 10. I'm just going to write it over here. Then take 10 and add it to 3. So I'm still in the same position, row 1, column 1. I just had to multiply this one by the scalar. And so that's 13. 2 times negative 2 is negative 4. Take that answer and add it to negative 8. So that's negative 12. And go to the next row. 2 times 1 is 2. Plus 2 is 4. 2 times 7 is 14. Plus 0 is still 14. 2 times negative 10 is negative 20. Plus 4 is negative 16. And 2 times 9 is 18. Plus negative 6, which is 12. So this is it for operations with matrices. Thumbs up, subscribe, have an awesome day.
Subscribe.